Hello everybody, welcome to lesson 6. This is going over function notation. So there's a few facts that you guys need to know before we start. First, if f of 2 equals 6, the point 2 comma 6 lies on f of x. The y-intercept of a function is always when x equals 0, and a function is undefined when its denominator is 0. So the first question, if f of 3 equals 31, what is a? So using our first fact that we learned up here, if f of 3 equals 31, then the point 3 comma 31 lies in this graph. And from unit 3, we learned that any point is x comma y. So f of x is just another way of saying y. So we could plug in 3 comma 31 into x and y. So 31 equals 3 to the a plus 4. Since we're solving for a, let's subtract 4 to the other side, then 3 to the a equals 27. And 3 to the third is 27, so a equals 3. Let's look at this one. So we know that 3 comma something lies on this graph because f of 3 is something. So if we know that 3 comma something lies on the graph, we could plug in 3 and this question mark in for x and y. So question mark equals 3 squared minus 3. 3 squared is 9, minus 3 is 6. So we know that f of 3 is 6. For what value of x is g of x undefined? Using our second fact that we learned, or our third fact that we learned up here, a function is undefined when its denominator is 0. So looking at this denominator here, we have to plug in some value of x that makes this equal to 0. Well, that's when x is 5. For the second question, we could use our second fact. The y-intercept of a function is when x is 0. So if we plug in 0, we have 1 minus 0 over 0 minus 5, which is 1 over negative 5. This is the y-intercept of a function. All right. So the questions we just did pertain to equations. Here, we're going to be looking at the same thing, but in graphical form. What is f of 1? So I'm going to call f of 1 question mark. So we know that the point 1 comma question mark lies in this graph. So when x, this means that x comma question mark lies in the graph. So when x is 1, f of x is 1, 2, 3, 4. That's a bad 4. 4. So the main takeaway here is that this is x, and then whatever f of x is, that's y. F of n equals 1. What are all possible values of n? So we know that this is y, and this is x. So when x is some value, y is 1. So let's look at all values that create that. Here, here, and here. So all possible values of n, negative 4.5, negative 1, and 5. For what value of x is f of x at its maximum? Now this is a tricky question because obviously the maximum value of f of x is 5 up here. But it's not asking for the maximum value of f of x. It's asking what value of x creates that maximum value. So we see here when x is this, f of x is at its maximum value over here. So when x is 3, f of x is at its maximum value. But what is the maximum value of f of x? That's just 5. That's when it reaches its highest point. For what value of x is f of x at its minimum? So we see the minimum point is here. That's at negative 3 comma negative 2. So we know that when x is negative 3, it's at its minimum value of negative 2. All right, let's continue. F of x equals 2x plus 4. If f of a equals 12, what is a? So we know that a comma 12 lies on f of x. So that means that we could plug in a for x and 12 for y. 12 equals 2a plus 4. 2a equals 8. a equals 4. G of x equals x to the m minus 8. If g of 2 equals 0, what is g of 3? So if g of 2 equals 0, 2 comma 0 lies on g of x. So that means we know that g of x is just y, so we could plug in 0 for y and 2 for x. So that means that 2 to the m equals 8 and m equals 3. So if m equals 3, we know that g of x is actually just x cubed minus 8. So if we want to find g of 3, so we could plug in x equals 3. So that means that 3 cubed is 27 minus 8 is 19. So g of 3 is 19. H of x is a linear function where h of 2 equals 5 and h of 4 equals 9. If h of k equals 15, what is k? All right, this is a big one. Here it says it's a linear function, so that means we know it's going to be a line. And using the fact that we learned earlier, if h of 2 equals 5, the point 2 comma 5 lies on h of x. And if h of 4 equals 9, the point 4 comma 9 lies on h of x. Using our knowledge from the third lesson, we know that we could find the equation of this line by finding the slope and then plugging in 1 point. So we find the slope by doing y2 minus y1, 9 minus 5 is 4, over x2 minus x1, 4 minus 2 is 2. So the slope here is 2. So y equals 2x plus b. So if we know that the point, let's plug in 2 comma 5. We know that that lies on this graph. So we could plug in 5 equals 2 times 2 is 4 plus b. So b equals 1. So that means you know that the equation of this line, h of x, equals 2x plus 1. Because we got our slope being 2 and our b value being 1. So we want to find h of k. We want to find k when h of k is 15. So we know that the point k comma 15 lies in this graph. That means we could plug in, since h of x is y, 15 for h of x and k for x. So 2k equals 14 and k equals 7. All right. F of x equals x plus 4. If f of m equals 3n and f of negative m equals n, what is n? So here we know that the point m comma 3n lies on the graph and negative m comma n lies on the graph. So let's plug in those values for x and f of x respectively. So we know that 3n equals m plus 4, and we know that n equals negative m. That's it. So here we could use, I'm just going to put plus 0 to make it similar. I'm going to use elimination to solve for n. So if we could add these two equations, cross these out, 4n equals 4, n equals 1. Done. All right, last few questions. If g of x equals x plus 5 and g of k equals k, what is k? So if g of k equals k, we know that the point k comma k lies in this graph. So since g of x is just y, we could plug in k for x and y. Here, using our knowledge of equations and system of equations from Unit 3, we know that these two lines have the same slope but different y-intercepts, so there's no solution for k. What is P of 3 increased by 450%? So first, let's find P of 3, then we'll use our knowledge from lesson 2 to increase that by 450%. So P of 3 is when x is 3, so 3 squared is 9, and 9 minus 5 is 4. So P of 3 equals 4. Now 4 increased by 450%. We know that x raised by y% is x times 1 plus y over 100. So P of 3, which is 4, increased by 450% is 4 times 1 plus 450 over 100. So 450 over 100 is 4.5, plus 1 is 5.5. So we really just have 4 times 5.5, which is 22. If you decrease P of 5 by a%, the result is P of root 21. What is a? So first, let's find P of 5 and P of root 21. We're using this equation again. P P of 5 is when x is 5. So 5 squared is 25 minus 5 is 20. So P of 5 equals 20. P of root 21 is root 21 squared, which is 21, minus 5 is 16. So P of root 21 is 16. So we know that x decreased by y% equals x times 1 minus y over 100. So if we're decreasing P of 5, which is 20, decreased by a%, so 20 times 1 minus a over 100 is equal to P of root 21, which is 16. So to get a by itself, we're going to divide by 20. 16 divided by 20 is just 16 over 20. This 20 cancels out. 16 over 20 is the same as 4 over 5. 4 over 5 is 0.8. So we have 1 minus a over 100 equals 0.8. 0.8 minus 1 is negative 0.2. So we have a over 100 equals negative 0.2, or negative a over 100. So then we could cancel out the negatives. Then a equals 0.2 times 100, which is 20. All right, that's function notation. I'll see you guys in the next video.